Hey guys, welcome back to AlgoYogi. We are doing linked list series. Our next problem is swapping nodes in a linked list. Let's go to the problem on LeetCode. So you are given the head of a linked list and an integer k. Return the head of the linked list after swapping the values of kth node from the beginning of the kth node and the end of the nth node, kth node from the end of the list. So basically in the first example, as you can see, so k is 2, second node from the beginning is 2, second node from the back is 4. Now we gotta swap both of them and then return the list, basically 1, 4, 3, 2, 5. All right, simple, easy peasy description. Let's see how we're gonna do it. Brute force approach, take an array, place these values, and then take the kth node from the beginning, take kth node from the back. So that would be n minus kth node from the back, and then just swap these two values and return it as 1, 2, 3, or I mean, you're gonna swap those values and then create a new list and return the head of that list. But that's using big of n time complexity, which is good, but it's also using big of n space complexity. That's where we can do better. So let's do better. So how about I know this is the kth node from the beginning. How about I find the kth node from back? So I'm gonna call that k minus back node, or maybe kth back, and this is kth beginning. All right, so this is it, and this is equal to basically k, and this will be equal to length of the list minus k. That would be the list, so that would be the node from the back. So here this is of length 5, so 5 minus 2 would be 3, and this is basically oh no, sorry, that's not what I meant. I meant basically second node from the back, but that second node from the back, what would be its position from the beginning? So because I can't really, this is not a doubly linked list, so I can't really traverse from the back of the list, so I need to find what is the back's position from the beginning, and that is L minus k plus 1. So that would be it. So 5 minus 2 plus 1 would be basically 5 minus 1, fourth. So fourth node, this is fourth node from the beginning also. So once we find those out, we will just need to replace these values. So I think that's easy peasy. So what I'll do is find the length. So I'm going to note down the steps. All right. Step 1, find the length of the list. So let's say length would be L. Okay, find the length. So I'm just gonna code it. Sorry about that. So find length. Once I find length, let's say it's L, step 2 would be traverse to the kth node for the front end. So traverse to kth front and traverse to kth back, and I know this will just be moving k minus 1 element next basically, and this will be L minus k minus 1 element into the front. So that will give us kth back, this will give us kth front, and just swap the values. All right, once we swap the values, then return the head. All right, let's implement this. Easy peasy. As I said, I'm gonna find out the length. Initially it's 0. Initially it would be 0. Curve is pointing to head. while cur, sorry, just being too fast. That was just bad. Okay, pointing to cur equals to cur.next. At the same time, I just want to increment my length. I have my length now. So kth node from the beginning, let's find out what it's going to. So let's say k, I'm going to call it kth node front. So from the front, that would start with head, but now I want to reach that particular node. So I'll do while, but before that, I want to save. I'm going to call it M, or let's say I'm going to call it M. This is what I'm saving for traversing for the node that will be from the back, but I still need to reach that node from the beginning. So I'm going to store that L minus K. So, and now I can just keep doing whatever I want to do with K. So if while K is greater than 0, so because I'm going to reduce it now, so K, I think I'm going to say it K minus 1, because right now in the first example, as you can see, K is 2, but to reach this node, since my head is already on 1, I just need one step to reach to 2, although it's not 2, but since I'm already on first node, it takes me only one step to reach there. So okay, let me zoom in again to the code. So kth from front, Control C, and would be basically dot next. All right, and I'm gonna decrement my K. Now at the same time, I want to have this node from the back. So I'm going to call it not just from the front, from the back also, back. And while M, so this time 5 minus 2 is 3, and I will need 1, 2, 3 steps. So this time I am not basically, I was supposed to minus 1 over here, but that's not what I'm going to do. So I'm just going to keep it like that. I'm not going to add this minus 1 over here, right? So while M is greater than 0, then what I want to do is take this kth node from back, and move it ahead by one by one, and M will decrement. So now after these two loops, we will have kth node from the front pointing to 2 from the beginning and pointing to 4, this kth from the back pointing to 4 from the end, basically, or from the beginning, you could say anything. Now I just need to take these two nodes and replace, basically swap those values. So I'm going to store, let's say, I'm just going to say it like this. So I'm going to take the value of kth from front, and I am gonna use that value to basically, so back's value is being assigned to the front, and front's value is being assigned from the temp that I stored from the front to the back. All right, I just said too many front to back, but I think this makes sense. So kth node front dot value, I'm just forgot to do this, val is coming from kth from back, and back's value is coming from front, that was stored in temp. All right, and then I can just finally return head. I think that will be all. Let me zoom out. Let's go over the code again. Calculating the length, which is L, then kth from front, kth from back, both pointing to head. Using K, I'm gonna use to the kth from the beginning, so kth node front beginning, and the back also goes to M. M comes from L minus K, and then basically I just swap those values using temp, and then I am gonna run it on examples. All right, and let's submit it. Hopefully it's efficient. Is it? I don't know. Let's see what it does. Not too efficient. I'm gonna submit it again. All right, but anyway, I'm gonna write down the time complexity, which is big of n is the number of node in the list. Worst case is n. Space complexity would be big of 1, constant time, since it is basically using constant time. I'm not storing anything here and there, but anyway. All right, this is done. So you gotta go back to AlgoYogi, mark this solved. Over here, a couple of problems remaining, but we are on the goal to solve all of it. All right, so see you guys in the next problem. Until then, bye bye.